force field can be defined as the region where an object experiences a force. In the case of a gravitational field, it is a region of space around a mass where another mass experiences a gravitational force.
Is there a way we can visualize this field?
Oh, absolutely. We can visualize it using field lines. Here's an example. For a point mass, the field lines are all directed towards itself.
I see. Does that mean an object placed near this mass will experience a force whose direction is given by those arrows?
Correct. The arrows of field lines show the direction that you just mentioned. Another important feature about field lines is their spacing.
Spacing? You mean how far apart the adjacent lines are from each other?
Yes. This spacing represents the strength of a field. The closer the lines are, the stronger the field, and vice versa. For example, the field lines for a less massive point mass would look like this.
All right, that's easy to visualize. Then, teacher, what would those field lines look like on the Earth?
Good question. Here, it might look something like this. Can you describe this?
It looks like these lines are parallel to each other and also equally spaced apart.
Excellent. This implies that the gravitational field on the surface of the Earth, on a scale comparable to the size of this building, is parallel and uniform. So, for small changes in height near the surface of the Earth, the field can be considered to be constant.
Yeah, I get that.
However, if you look at the gravitational field lines in a much larger scale, it would look something like this.
Whoa! At this scale, it seems that all the lines are going inside the Earth.
Yes, to be exact, the lines are pointing towards the Earth's center.
Is there any particular reason why this is the case, or is Earth special in some way?
Nope. The reason behind this is a sphere whose mass is uniformly distributed behaves as a point mass and hence has the same field lines as if all the mass was concentrated at its center.
Oh yeah, we did use this assumption in the previous lesson as well. But teacher, the mass of the Earth isn't uniformly distributed, right? We have oceans, deserts, and mountains spread across the surface of the Earth.
That's a good question. But recall the example of the field lines for a building. It's all a matter of scale. For a satellite or yourself, the fluctuations of mass distribution that you mentioned would be extremely negligible.
Gotcha. The Earth is pretty massive compared to me or a satellite, I guess.
Indeed.
All right, teacher. I think I know how to visualize gravitational field lines for point masses and the Earth. But is there a way to measure this field?
Absolutely, there is. We measure it with a quantity called the gravitational field strength. The gravitational field strength at a point is defined as the force per unit mass acting on a small mass placed at that point.
That looks familiar. F divided by m. Wait a minute, that's g, right? Acceleration due to gravity or acceleration of free fall.
Spot on. We've used this g time and again. Near the surface of the Earth, gravitational field strength is equal to 9.81 newtons per kilogram.
So in this case, the force would be the weight of the object.
Correct. I hope you can see why these two things are equivalent. This is because weight is the force that a mass experiences due to the gravitational field of the Earth.
Yup, and I've already learned that Earth is pulling every object towards its center, which matches with the direction of field strength of Earth.
Want to learn more? We have additional learning resources to offer. for Cambridge IGCSE and AS A-level subjects. Register now for free.